Okay, so I know you're still working through it. That's totally fine. I'm just going to go through it on the board and see how you fare against what I get. Okay, so we've got to find the first three terms of the Taylor series expansion of f of x equals this particular function. A little bit more awkward to differentiate. That's the only difference between this and the last one. But we've got x equals 0, so it might be a little bit easier to substitute values in. Okay, so let's start off with f of x. So that is just sine of pi by 6 e to the 2x. Now, first of all, let's think about the derivative. So the derivative of f of x. So clearly we've got a function buried within inside another function. So we're going to have to be using the chain rule. Okay? So what's the derivative of sine? Let's differentiate the outside first. What's the derivative of sine?
Minus cosine.
Cosine.
Just cosine. Yeah, just think about the circle. Yeah. So you're close, but yeah. So cosine of, leave the inside one alone, so pi by 6 e to the 2x. What are we going to have to multiply by? Derivative of that. So what do you reckon?
2 pi divided by 6 e to x.
Yeah, perfect. So the pi by 6 is just a constant. E to the 2x, if you differentiate that, that becomes 2 e to the 2x. It's actually chain rule buried within that. So it becomes 2 pi divided by 6, or pi divided by 3 e to the 2x. Same thing, right? Same thing, you wouldn't lose in maths there. Does that make sense? Yep. Okay, second derivative, going to have to use the, what are we going to have to use if we want to differentiate this?
Do the multiplication rule.
Yeah, product rule, perfect. So product rule, remember, really easy. You just have to differentiate that, leave that alone, added to, derivative of that, leave that alone. Right, so you literally just each one gets its chance of differentiated, and you just leave the other one alone in each of those cases. So let's start off here, because it's very similar to what we did before. So what's the derivative of cosine of pi by 6 e to the 2x?
Minus sine.
Perfect, yep. So negative sine, pi by 6 e to the 2x, so leave the inside one alone. Yeah. Multiplied by, so we haven't finished differentiating this, so what's the derivative of this?
Pi by 3. Yeah, the same.
Exactly the same, yep, pi by 3 e to the 2x. Now the thing which you need to remember here, we still need to multiply with the second function, because we've left that alone, right? So we need to multiply that with pi by 3 e to the 2x. Now if you like, because you've just got these two things multiplied together, you could just get rid of that and just square all of this, right? That's fine. Do you see where I've done that? Just that simplification? Yep. Okay, then I'm going to add that to, so this time round, I'm going to leave that function alone. So I'm just going to write that in now, just so I don't forget it. Cos of pi by 6 e to the 2x. Then I'm going to multiply it with the derivative of that. So what's the derivative of pi by 3 e to the 2x? Just that part there. Ignore the pi by 3 then. What's the derivative of e to the 2x?
2e to the 2x.
Good. And then just multiply by pi by 3. Yeah. So it becomes 2 pi by 3 e to the 2x. Happy with that? Okay. So actually now all I need to do, okay, is substitute in x equals 0 into each of these three things. Now I'm losing space a little bit, so let's see how I get on. Okay, let's consider my original function then first of all at the point x equals 0. So this is all I do now. So I've differentiated a couple of times because I need three terms, right? Now all I do is just go back and stick in the point which I'm approximating around, okay? So if I stick in 0 in here, what do I get?
Sin pi by 6.
Yeah, sine of, because that's just 1, e to the power of 0 is just 1, right? So 1 times pi by 6 is just pi by 6. Sine of pi by 6 is...
I know you don't need this.
half, right? Same as sine of 30, okay? Of course, you've got a calculator, so you don't have to physically do that, right? Okay, let's do the same thing this time with my first derivative. So my first derivative at the point x equals 0. Well, okay, cos of pi by 6, because first of all that's e to the power 0, so that's just 1 again. So cos of pi by 6, what's that? Root 3 over 2. Times by, again calculator, so don't have to worry about knowing these. Pi by 3 times by 1, right? So if I times that by pi by 3, let's just tidy that up slightly. I'm going to get root 3 times pi divided by 6. You happy with that? Root 3 over 2 times pi by 3. Okay, let's put this one down here because I'm running out of space a little bit. So let's do my second derivative evaluated at 0. Let's break it down first of all. Let's do this part, okay? So sine of, or negative sine of, pi by 6 times by e to the power 0. That's the same as negative sine of pi by 6. Well, sine of pi by 6 we saw above was a half, so it's going to become negative a half, right? So I'll just write it in piece by piece first of all. Then I need to multiply that with when I stick 0 in this part. So pi by 3 e to the power of 0 is just going to be pi by 3, and then I need to square that. So that's going to become pi squared over 9. Square the top, square the bottom. Make sense? Okay, then I'm going to add that to, right, cos of pi by 6 times by 0, e to the power 0, which is cos of pi by 6, which is?
Root 3 over 2.
Perfect, root 3 over 2, well done. And then I want to times that with 2 pi over 3 times by e to the power 0. That's just going to be?
2 pi over 3.
Great. Now I am just going to work with this a little bit because I think we can do a little bit of tidying. So that's going to become, I'm going to put this one first. 2's cancel, root 3 over 3 times pi. So I'll go, that's root 3 pi over 3.
Plus.
Minus, we'll do this one next. Pi squared over 18. That makes sense? Yeah. And I guess well, let's put it as all as 1, right? Let's put it all as one fraction. So that's going to become, if I times top and bottom by 6, that's going to become 6 pi times root 3 minus pi squared all over 18. Happy with that?
Yeah.
Okay. That's the hardest part done. Now it's just a case of putting it together, okay? So really with Taylor series, the hardest part is taking a function and differentiating it, okay? All we're doing over here in blue is just sticking in the point which we want to approximate around. So this part is really the hardest part, okay? And this, sticking it in, you can stick all that in your calculator, okay? So now all we need to do is the easy part, which is put it all together. So we are saying that f of x is going to be approximated by f of a. That's a half. Plus f prime of a, that's going to be root 3 times pi over 6, times by x minus a, that's going to be x minus 0, or just x. Happy with that? Right? And then we're going to add on the second derivative at a, that's this thing, divide all of that by 2 factorial, okay? So if I take this whole fraction, divide it by 2 factorial, that's just 2, that's going to become that numerator over 36. Does that make sense? Right? So we'll have 6 pi root 3 minus pi squared all divided by 36 times by x minus 0, remember, so that's just x, and just square it.
Yeah.
Yep. That's it.